Now that we had a look at packages and modules, really as a last concept that I want to introduce in this basic section, I want to talk about variables that never change. And for this, I took an example from the second exercise I gave you. And in case you skipped that, you find that exercise Go file attached. And it's a very simple file, as you can tell, just has a package instruction and then a variable in it. But this variable is special. This, of course, is a variable, pi, which holds 3.14 as a value, and that, therefore, is a variable that will never change. Of course, in our current demo application here, most variables never change. We have a lot of values that get a value once and then never change, but they could change. They are all intermediate results. In a real application, they might be changing because of new user input or anything like that. But if we have a little package that helps us with mathematical calculations, we might have a variable like pi defined in there, which definitely never changes because the value pi is clearly defined. Now, in such cases, you can use a variable like this. You can create it as you learned it, but you can also turn this into a constant, which is a clear signal to Go that this value should never change, and which will throw an error if you ever try to change it somewhere. So where you can avoid unintended changes and therefore make your code a bit safer and protect yourselves against unintended changes. And you do that by replacing the var keyword with the const keyword. When you do that, you create a variable as before, with the important difference that it's not really a variable. You can't assign a new value to it. Now, you can't create such a constant with any shortcut. Instead, you always need to use the const keyword, and then you can pick any name you want, following the same name conventions as we have it for variables. And then you can store any value you want, but very important, this has to be a value that is known at the time of the compilation already, so before your code executes. So you can't store some user input here or anything like that. So data that you fetch once the application started, that can't be stored here. Instead, it has to be a value that you already know at the point of time you're writing the code, basically. But with that, you can then use this constant just as you use variables. For example, in firstapp.go, at the bottom, I'm outputting it here. I'm outputting pi. I'm doing it like this since they are in the same package, so no import is needed. And with that, we make it very clear that pi does never change. And if we try to assign a new value, we therefore get an error where we learn that it's a constant and therefore we're not allowed to assign a new value to it. And that can harden our code. It can make our code a bit safer. And especially if we work on a bigger project and or in a bigger team, we might want to lock down certain variables to avoid unintended changes that could break other parts of the program. And constants are a useful feature for that. Now that's it for this basics course section. It was a huge section, lots of concepts, a lot of explanations, but this is the foundation you need to build any Go program. So make sure you understood all those concepts, because we learned how a Go file is generally structured, that we have this concept of modules and packages, and that we can split our code across multiple files that belong to the same package or that belong to different packages, that we have to import functionalities from other packages if we want to use them in another file. And we learned about all the key basics, the fundamentals like variables, values, and value types like strings and integers and floats. We learned how to do mathematical operations and that sometimes we need to convert values from one type to another type in order to work with them correctly. We also learned about outputting data with help of println, or how to output or create strings in a more formatted way with greater control with help of the printf functions, which are built into the format package. And we learned how those worked as well. We also, of course, did have a look at more exotic data types like runes and bytes, but we'll see them again later in the course once we need them. For the moment, it's enough if you heard about them. Now, we did, of course, also learn a lot about the Go syntax in general, that we omit semicolons even though they are added behind the scenes, how you should name your files and your variables, like this using mixed case. And we learned that the naming should not just be descriptive, but that it also signals whether something can be used in other packages as well. Starting with a lowercase character, you can only use that variable or function in the same package. If you start with an uppercase character, you can use it in other packages as well once you imported this package. We also learned about constants, which are very useful if you have values that can and should never change. And therefore, overall, we now have the foundation we need to dive deeper. In the next course section, we'll build a little demo project, which is more useful than the dummy code we wrote in this course section. And we're also going to dive into a few selected new features, like getting user input from the command line, and then thereafter we'll dive even deeper into Go. In the previous course section, we explored those fundamental concepts of values, variables, types, modules, and packages. In this course section, we are going to practice these concepts a little bit more, and we are going to build a basic first app that is a bit more realistic and useful than the dummy code we wrote in the previous course section. We're going to build a BMI, a body mass index calculator. So we're going to build this application, which runs in a command line, where the user of this application is prompted to enter his or her height and weight, height in meters and weight in kilograms, and will then calculate the body mass index of that user based on that user input. That's what we're going to build, and whilst building this, we are going to practice working with variables, values, and types, since we'll need different kinds of values and types for this application here. We are going to build a new module and also split our code into multiple files and packages to practice that again, and we'll dive into a brand new feature, something we haven't done before. We will also learn how to read user input from the command line, because of course this application, in order to work correctly, needs to prompt the user for some input, which then is entered in the command line and which then is used in the running application. That's what we're going to build in this course section to practice what we learned. Now, to build this, I'm back in an empty folder opened up in Visual Studio Code, and I will start by creating a new Go module here. So before I even add any Go code, I'll turn this into a module. For that, I'll open this integrated terminal, and you learned that you do create a new module in a folder by running the go mod init command, and that's what I'll do here therefore. And then we have to give this an identifier, and I will again use github.com/ and then I'll pick /m Schwarzmuller, which is my name, my organization name here, and then BMI for body mass index. Now again, this identifier is generally up to you. It doesn't matter too much right now. If you should ever plan to distribute your Go project as a library others can download, you need to use an identifier that actually leads to your source code, so that leads to the actual GitHub repository you might be using for hosting the source code. But for the moment, we're not doing that, and therefore this should just be any identifier that makes sense to you, but I will follow this pattern of picking a URL here. So that's the identifier I will use, and then I'll hit enter. Now with that done, this go.mod file was added, and we can leave that file as it is. And we now also want to add another file here, the file that holds the actual source code, though I will already say that throughout this course section, we are going to split our code across multiple files and packages simply to practice this again as well. But here I'll start with a first code file, and I'll name it bmi.go, since this will be the starting point, the main entry point for my overall BMI application. The name is up to you. You could also name it differently. It doesn't have to be named like your last part of this module here, but I will do it since that makes it very clear that this overall code here is about calculating some body mass index. Now in this bmi.go file, I'll first of all start by defining to which package this belongs. And every Go file should belong to a package. And this will belong to the main package, and it should belong to the main package because Go will look for a main package with a main function to execute this overall module once you, build and or run this module. So in order to use go run dot, for example, and execute the overall module, we need to use main as a package name because that is the package Go will look for as a default then. So here I'll pick main as a package name, and then in there add my main function as we did it before in this course as well. And that will be the first function that will be executed by Go when we run this module as an application. And here, just to see that everything works, I just want to output hello world as a start. And for that, I'll use the FMT package. We can type it here and hit tab to let the Go extension add this import for us. And I'll then just execute println and say hello world again like this. Save everything. And then open that terminal and run go run dot to execute the overall module, and that should work and show hello world. And if I would use a different package name like BMI, for example, then if I try this, you see that I get an error and that it fails to run a non-main package. So this must be named main. But with that, we get our starting setup, we got the first code file in place, and we created a module. And now we can start working on the actual functionality for this BMI application.